Hello everyone, this is Sara Bouziane, a first-year PhD student at the Faculty of Science of Meknes, Moulay Ismail University, Meknes, Morocco. I'm here to present the work titled The Use of Big Data in Water Resources Management, carried out by me, Professor Badraddine Aghoutane, Professor Aniss Moumen, Professor Sahlaoui, and Professor Aniss Ouali. I would like to thank the organizer for accepting our work. We will follow this plan. At first, we present the water scarcity situation in the world, and particularly in Morocco. After that, we describe the methodology of our literature review and the meta-analysis of documents in our datasets. At the end, we present some of the proposed architectures, and we finish by a conclusion and our perspective. So water scarcity has become a common concern for the decision makers in the world, particularly in Morocco, and since independence, water has become or has been considered as an essential component of the economy. And this perspective, King Mohammed VI launches 150.4 billion dirham program to secure water supply up to 2027. And to highlight this strategy, in the right we have different Moroccan authorities for the water management under the coordination of the Higher Council Water and Climate Interdepartmental Commission of Water, which are planning and decision-making authorities and the public institutions and water users. That allowed us to generate water data at multiple levels of the management process. As shown in the slide, we can notice that we have source water data such as water quality, hydrometric data, and dam data. Also, we can have groundwater data such as piezometric level data and water quality. Also, we can have climate data such as temperature, evaporation, rainfall, wind, and humidity. That's why water stakeholders have started to look for solutions based on big data and Internet of Things technologies to deal with the water resources management problem. So we can use big data for water data analysis and to make the right decisions. We can use the Internet of Things based on smart devices, connected smart devices, for data collecting and data smart monitoring. We can also use the cloud computing for the data storage in a secure way. So this is our working methodology. We've started by the constitution of the Zotero library from different databases such as I3E database, Science Direct database, Scopus database, and Google Scholar database that was using keywords such as big data, war, information system, and Internet of Things. So at first we have got 226 articles, and after cleaning and removing the excluded articles, we've got 119. After that, we export the RIS file to the in-vivo tool for treatments and analysis. So let's go to the meta-analysis of our results. And as shown on the slide, we have the table of references categories, and we can realize that we have got 110 as a journal articles, 76 conference papers, and only 4 chapters and books. We have a total of 190 articles. And for the journals, sources of our articles, we notice that we have 6 articles from the Advances in Intelligent Systems and Computing journal, and 5 articles from the Environmental and Modeling and Software journal. And about percentage of references by database, we notice that the most of our documents are from the Scopus database, followed by the I3E Explore database with 34% of our references, 21% of our documents are from the Science Direct database, and only 4% are from Google Scholar database. This is a graphical presentation of research resources per year. We have a first peak in 2015 and another peak in the year of 2020. About languages, we have 188 articles in English and 2 articles in French. Let's go to the word analysis of our study. This is the word cloud of our dataset, and we notice that word and data are the two most used or cited words in our dataset, and this is also illustrated in the graph at right. At left, we have a table presenting the number of documents by domain of application. We have 180 articles presenting about war, and at left we have a table presenting number of documents by technology, and we can see that 178 articles are talking about big data. This is normal because war and big data are the two most frequent words in our dataset. That allowed us to have the crossover of cited technologies and domain of application, and we have 169 articles talking about big data in the field of applications of war, and we have 23 articles presenting architectures about war management. So we have chose 3 of those architectures that we will present in this presentation. The first is the architecture proposed by Ridwan Sharh et al., presenting the first part of a big data open platform that can manage and process a massive volume of war data collected from different sources and anticipate and avoid catastrophic situations such as floods and droughts. This part is developed and based on G2 technology and provides better decision making related to the management of natural resources. The presented model, as shown in the slide, is composed of 9 blocks. The second is a model proposed by Huanchan Ma et al., presenting a big data system for China's war ecological data management, which the primary services are the control of measurement of the war environmental data, so we can use them in environmental protection projects, such as the government of the nutritional value of war bodies, so it helps in fisheries, and also it serves in the domains of the war conservancy engineering and coastal engineering by providing data support for environmental protection strategies of war conservancy projects and some coastal projects. The third, it's the IFC Cloud Network architecture proposed by Siu et al. It's developed by the AWA Fluid Center. The main objective of this infrastructure is to explore rainfall metadata and generate rainfall products over the AWA domain. The objective of this presentation is to present an exploratory study of research works on big data technologies and their use in the field of war. Our perspectives are to study different published works about machine learning algorithms and models for collecting war data in order to propose our architectures of a big data system for war management.